There is a process happening inside every cell of your body right now that most doctors never mention, that no supplement can replicate, and that requires absolutely zero effort, zero equipment, and zero cost to activate. It can repair damaged DNA, dissolve the debris that accumulates in your brain, reduce the inflammation driving most chronic disease, and extend the healthy lifespan of nearly every organism scientists have ever tested it on. And it turns off the moment you eat. Yoshinori Osumi, a Japanese cell biologist, spent decades studying what happens inside a cell when food disappears. What he found was so significant that in 2016 he was awarded the Nobel Prize in Physiology or Medicine for it. The body, it turns out, does not simply wait when it runs out of incoming fuel. It switches modes entirely. It begins to eat itself not destructively, but with surgical precision dismantling its oldest, most damaged components and rebuilding them from scratch. It is the most sophisticated recycling system ever discovered, and it has been sitting dormant inside you every single day you skipped it by reaching for a snack. The mechanism is called autophagy, and it only runs when the pantry is empty. Now here is the thing most people get completely backwards. Feel your stomach right now. If it has been a few hours since you last ate, there is probably a low hum of hunger there, maybe a slight hollow feeling. Your entire life, you have been trained to interpret that sensation as a warning, as a biological emergency requiring immediate resolution. Eat something, quickly, top off the tank before it runs dry. But that signal is not a fuel gauge. It is a hormone called ghrelin, and it pulses in waves. It rises for roughly 20 minutes. Then, whether or not you eat, it falls. The hunger is not a straight line dropping towards zero, it is a wave. And if you let it pass, which almost no one ever does, it simply recedes, and your body quietly switches to a fuel source it has been storing for exactly this moment. The fat sitting in your cells, carrying enough calories to run you for weeks. Your body is not a car with a 10-liter tank. It is a hybrid engine with two completely separate fuel systems. The first runs on glucose fast, convenient, and stored in tiny amounts in your liver and blood, enough for maybe a day of casual activity. The second runs on fat slower to access, but enormous in capacity. Even a lean adult carries the equivalent of over 100,000 calories in stored body fat. The body didn't build that storage by accident. It built it because for 99% of human evolutionary history, food was not a constant, it was intermittent. And the organisms that could not only survive but sharpen during the gaps, the ones who got faster and more focused when hungry, not slower and confused, were the ones who lived to eat again. This is not a philosophy about eating less. This is basic engineering. The reason a hungry predator is the most dangerous version of itself, alert, locked in, every sense tuned, is not a coincidence. It is a design feature. Fasting does not weaken the brain. It upgrades it. Ketones, the fuel your liver produces when glucose disappears, are not a backup fuel. They are, calorie for calorie, a cleaner and more efficient energy source for neurons than glucose. Studies on cognitive performance under mild fasting consistently show improvements in working memory, processing speed, and focus. The foggy, slow, irritable feeling people associate with skipping a meal is almost always the result of blood sugar crashing after too much food, not the result of too little. And here is where the real machinery becomes visible. Every time you eat, your body releases a hormone called insulin. Insulin's job is to move glucose out of the blood and into cells for storage. It is an extraordinarily powerful signal, and while it is circulating, it acts as a lock on your fat stores. As long as insulin is present, the deep freezer stays shut. You cannot access the fat you've stored, no matter how much of it is sitting there. The only key that opens that lock is the absence of food. When insulin falls, which it begins to do within hours of your last meal, the lock opens, glucagon rises, and the body begins to migrate toward its secondary fuel system with a quiet, practiced efficiency it has been refining for millions of years. Most people in the modern world never reach this state, not because the body has forgotten how, but because we eat again before it gets the chance. The average adult today eats across a window of 14 to 16 hours per day. That leaves the body 8 to 10 hours, mostly while sleeping, to access its fat stores, run its cellular maintenance cycles, and activate autophagy. And for many people, that window is shorter still. A late-night snack, a glass of juice in the morning, a handful of something mid-evening, each one of those resets the insulin clock and shuts the freezer door again. The trash collectors never come. The maintenance crew never gets the signal. The cellular debris accumulates. Not because the system is broken, because it never gets quiet enough to run. Your body runs on two completely separate fuel systems, and understanding how they relate to each other changes everything about how you think about hunger, energy, and fat. The first system runs on glucose. It is fast, immediate, and always first in line. When you eat anything with carbohydrates, and to a lesser extent protein, your digestive system breaks it down into glucose, ships it into your bloodstream, and your cells burn it within hours. It is the closest thing your body has to cash in hand. Convenient, liquid, and gone quickly. The liver and muscles can store a small reserve of it as glycogen, enough to fuel roughly 12 to 18 hours of moderate activity. That is your pantry. Small, close to the kitchen, and easy to restock. The second system runs on fat. And this is where most people's mental model completely breaks down. Fat is not stored because the body made a mistake. It is not excess that the body failed to process. It is your deep freeze, a deliberately engineered high-density fuel reserve that the body built specifically for the gaps between meals. Even someone who looks lean by any conventional measure is carrying 30 to 50,000 calories in stored fat. An average adult carries enough to walk from Lagos to Abuja and back, twice, without eating a single meal. The body did not build that reserve hoping you would never use it. It built it because using it was always the plan. What nobody told you is that the plan requires a specific condition to activate, and that condition is the one modern life almost never allows. The switch between these two systems, from glucose to fat, from pantry to deep freeze, does not happen automatically just because you feel a little hungry. It is gated, and the gatekeeper is insulin. Every time food enters your system, your pancreas releases insulin. The amount it releases scales with how much glucose and how quickly enters your blood. A bowl of white rice spikes it sharply. A handful of nuts raises it gently. A glass of water does not move it at all. Insulin's primary job is to act as a traffic director, escorting glucose out of the blood and into cells before blood sugar rises to dangerous levels. It does this job extraordinarily well. But insulin does something else at the same time, something almost no one talks about. It locks the fat stores shut. Think of it as a physical key. While insulin is circulating, which it will be for 2 to 4 hours after any meaningful meal, and sometimes longer, the enzyme that breaks down stored fat is chemically suppressed. The door to the deep freeze is not just closed, it is locked from the outside. Your fat cells are literally inaccessible. You can feel depleted, tired, craving energy. And your body will still refuse to open those stores as long as insulin is present. The signal that says use the reserve and the signal that says I just ate cannot coexist. One shuts off the other. Every time you eat even something small, even something that seems harmless, the clock resets, the lock goes back on, the reserve stays sealed. This is why constant snacking, despite often being marketed as a metabolic strategy, does the precise opposite of what its advocates promise. If you eat every 2 to 3 hours, insulin never fully clears. The body remains in storage mode continuously. It builds, it deposits, it manages incoming glucose, but it never receives the signal to switch tracks. The deep freeze collects more and more over the months and years, and the key to open it never gets used, because the condition required to produce that key, falling insulin, rising glucagon, the quiet hours after a meal has fully cleared, never arrives. Now here is where the hunger story becomes strange and important. Most people assume that hunger intensifies in a straight line the longer they go without eating. That if you skip lunch, you feel a little hungry at noon, hungrier at 1, ravenous by 2, and completely dysfunctional by 3. This is not what actually happens in the body. What actually happens is considerably more interesting. Hunger is driven primarily by a hormone called ghrelin, produced in the stomach lining. Ghrelin rises in anticipation of meals. It is partly trained by your eating schedule, which is why you feel hungry at the times you normally eat, even when you are not biologically depleted. But ghrelin does not rise forever. It peaks. Then, whether or not you eat, it falls. The wave crests and recedes on roughly a 20-minute cycle, which means the most intense feeling of hunger you experience, the sharp, insistent pull that feels like a biological emergency, has a ceiling. It will be gone within 20 minutes if you simply allow it to pass. This matters enormously because most people have never tested it. They have responded to every ghrelin wave their entire adult lives. The signal arrives, they eat, the signal disappears, and they log that as evidence that eating solved the problem. But the signal would have disappeared anyway. You just never stayed in the room long enough to watch it leave on its own. What happens if you do stay in the room? What happens in the body during those quiet hours when insulin has cleared, ghrelin has come and gone, and the fat stores finally have an open line to the rest of the system? Two things begin that almost no one in modern life ever allows to fully run. The first is metabolic switching. As insulin falls and glucagon rises, glucagon being the counter hormone that says release energy, not store it, the liver begins converting stored fat into ketone bodies. Ketones are not a desperation fuel. They are not what the body produces reluctantly when it has no other choice. They are a highly refined, energy-dense molecule that the brain and heart actually prefer under certain conditions, and that burn with considerably less oxidative byproduct than glucose. The mild cognitive sharpness many people notice after not eating for 12 or more hours, the sense that things are slightly clearer, slightly more focused, is not willpower. It is the brain running on cleaner fuel. Ancient predators did not become sluggish and confused when food was scarce. They became sharper. Their working memory improved. Their sensory attention narrowed and focused. There is a reason the hunter who had not eaten in 18 hours was more dangerous than the one who had just finished a meal, and it has nothing to do with motivation. It has to do with ketones crossing the blood-brain barrier and increasing the efficiency of neural signaling. This is what the research now calls the hunter's edge. The state of mild metabolic fasting does not compromise the brain. It unlocks a performance mode the brain evolved to run in during exactly these conditions. The second process that begins in the fasting state is stranger, more intimate, and arguably more important for long-term health than any other biological mechanism your body possesses. It is called autophagy. The word comes from the Greek autos, meaning self-phagein, meaning to eat, self-eating. And while that sounds alarming, what it actually describes is one of the most elegantly engineered maintenance systems in all of biology. Every cell in your body accumulates debris over time. Misfolded proteins that did not assemble correctly. Damaged mitochondria that are generating more waste than energy. Fragments of viral or bacterial material that bypass the immune system. Oxidized lipids. Molecular garbage of every description. Under normal conditions, the fed state, the constant eating state, the cell is in build mode. Insulin is high, mTOR is active, the cell is focused on growth and production. There is no signal to clean. There is barely even a pathway open for cleaning. But when the fasting state arrives, when insulin has been low long enough, when a protein sensor called AMPK detects falling energy and activates a cascade of downstream signals, the cell opens a set of membranes called autophagosomes. These membranes engulf the accumulated debris, fuse with the cell's internal digestive machinery, and break the waste down into raw molecular components. Amino acids, lipids, sugars, the exact building blocks the cell needs for repair and renewal. The garbage is not thrown away. It is disassembled and reused. The trash collector is also a factory. What gets cleaned in autophagy is not trivial. The process selectively targets the structures most associated with aging and disease. Damaged mitochondria, the cellular components most linked to inflammation, neurodegeneration, and metabolic dysfunction, are a primary target. So are misfolded proteins, the accumulation of which is directly implicated in Alzheimer's, Parkinson's, and a range of other conditions. The Nobel Committee's reasoning for awarding Osumi its highest prize in medicine was not ceremonial. It was because the implications of autophagy for human health are difficult to overstate. A system that runs automatically, costs nothing to activate, requires no pharmaceutical intervention, and specifically dismantles the cellular structures most responsible for chronic disease. And the only thing standing between you and its full operation is giving it enough quiet hours to run. The reason these 5 mechanisms, the fuel switch, the insulin lock, the hunger wave, the ketone edge, and the cellular janitor belong together in a single story is that they are not separate features. They are one system. They are the same ancient program running in sequence, each step unlocking the next. Insulin falls. The fat stores open. The liver begins producing ketones. The brain shifts into a cleaner, sharper mode of operation. And deep inside the cells that make up every organ in your body, a set of membranes quietly open, begin their work, and start dismantling the debris that has been accumulating since the last time you gave them enough silence to function. Your body was not designed to be fed continuously. It was designed to cycle, and the cycle does not work if one half of it never runs. There is a persistent fear sitting underneath almost every conversation about fasting, and it needs to be addressed directly before anything else. The fear is this, that without a constant supply of dietary protein and calories, the body will begin consuming its own muscle, that skipping meals is a slow act of self-destruction, that the person who fasts is trading metabolic flexibility for physical deterioration. This fear is not only wrong, it is almost precisely backwards. When the body enters the fasting state and begins its shift toward fat metabolism, one of the most powerful hormonal responses it produces is a dramatic spike in human growth hormone. In men, studies have measured increases of up to 2,000% above baseline over a 24-hour fast. In women, the increases are somewhat lower but still extraordinary by any physiological standard. Growth hormone does not build muscle from nothing that requires training stimulus and adequate protein over time, but its primary role during fasting is protective. It signals the body to preserve lean tissue at almost any cost. It is the reason a hunter who had not eaten in 2 days was still physically capable of running down prey. The body needed that muscle. It needed that bone density. And it had a mechanism, refined over millions of years, to ensure those assets were protected during lean periods by shifting all available energy extraction toward fat reserves and away from structural tissue. The idea that the body turns to muscle for fuel within hours of a skipped meal misunderstands the entire architecture of human energy management. Muscle catabolism, genuine breakdown of structural tissue for fuel, occurs under extreme and prolonged starvation, not after missing lunch. The growth hormone spike is part of the reason why. It acts as a biological preservation order, issued automatically the moment the fasting state is detected, ensuring that the machinery required to survive the gap remains fully intact until the next meal arrives. But growth hormone is not the only system given room to breathe when eating stops. Consider what happens inside your digestive tract every single time food enters it. The process of digestion is, from the immune system's perspective, a controlled emergency. Food is foreign material. It contains bacteria, fragments of plant and animal cells, proteins that have never existed inside your body before, and trace amounts of substances the immune system has no prior record of. Every meal triggers a low-level immune response in the gut, lining a mobilization of surveillance cells, an increase in inflammatory signaling, a careful inspection of everything passing through. Most of the time, this response is managed so smoothly that you never notice it, but it is never free. It costs energy, it costs immune attention, and over a lifetime of eating every few hours, it accumulates. The gut lining itself, a single layer of epithelial cells separating the contents of your intestine from your bloodstream, is one of the most metabolically active tissues in the body. It renews itself completely every 3 to 5 days. It requires constant resources. And when it is continuously processing food, it has limited opportunity for the deeper repair cycles that keep it structurally sound. A compromised gut lining is not just a digestive inconvenience. It is one of the primary drivers of systemic inflammation, the kind that circulates through the bloodstream, settles into joints and arterial walls, and shows up years later as conditions that seem entirely unrelated to digestion. Fasting gives the gut silence. It gives the immune system a reprieve from its continuous inspection duties. The inflammatory burden drops. The repair cycles run. The lining has hours, sometimes the first uninterrupted hours in years, to consolidate and strengthen. The immune cells that were perpetually stationed at the gut wall are freed for other work. This is not a side effect of fasting. It is one of its central physiological functions, systemic rest for a system that in the modern world almost never gets any. Now return for a moment to the fuel architecture, because the full picture of where the body's energy actually comes from during a fast is more layered than most people realize. The pantry liver glycogen, blood glucose, is the first resource the body draws from. It is fast to access, immediately usable, and the preferred fuel for the brain under normal conditions. But it is small, 12 to 18 hours of moderate activity, and it is substantially depleted. This is where most people's understanding of fasting ends, as though depletion of glycogen means the body has run out of options. What actually happens next is the opposite of running out. The body does not hit a wall, it opens a door. The deep freeze your adipose tissue, the fat distributed across your hips, abdomen, thighs, and the depots surrounding your organs contains energy in quantities that dwarf the pantry by an almost incomprehensible margin. 100,000 calories in a person of average weight. Enough to sustain full physiological function for weeks. The body has been depositing into this account for years, methodically, carefully, in response to every meal that provided more energy than was immediately needed. It built this reserve with enormous biological investment. And its plan, the plan it has always had, was to spend it during the gaps. Not to hoard it indefinitely while running the body on a perpetual drip of incoming glucose, to actually use it. The fat cells release their stored triglycerides into the bloodstream. The liver converts them into ketone bodies. The muscles, heart, and brain shift their metabolic machinery to accept this new fuel. And the body discovers, sometimes for the first time in the life of the person living inside it, that the deep freeze was always there, always full, always available, waiting for the insulin lock to open. But perhaps the deepest and most consequential thing that happens during a fast has nothing to do with fuel at all. Inside the nucleus of every cell in your body, your DNA is under constant low-level assault. Ultraviolet radiation, oxidative stress, the byproducts of normal metabolic activity, all of these create errors in the genetic code. Strand breaks, miscopied sequences, structural damage that accumulates over decades. The body has repair mechanisms for this. Sophisticated molecular machinery that moves along the DNA strand, detects errors, and corrects them. But like autophagy, these repair processes require a specific condition to run at full capacity. They require the cell to be in a state of low energy availability, the state that signals, at the deepest molecular level, that resources are scarce and preservation is the priority. The proteins responsible for orchestrating much of this repair are called sirtuins. They are sometimes called longevity genes, not because they are magical, but because organisms with higher sirtuin activity consistently live longer, age more slowly, and show greater resistance to the diseases associated with cellular aging. Sirtuins regulate DNA repair, control the expression of inflammatory genes, manage mitochondrial health, and coordinate the cell's response to stress in ways that consistently favor long-term survival over short-term growth. They are activated by a molecule called NAD+, the availability of which increases during fasting. And they are suppressed by the constant presence of insulin, mTOR activation, and the biochemical signature of the perpetually fed state. The implications are not subtle. A body that never fasts is a body in which the sirtuin pathway, one of the most conserved and powerful longevity mechanisms in biology, runs at a fraction of its potential. Not because it is broken, because the signal required to activate it never arrives. So what does this mean practically? What does it actually look like to give these systems the fat-burning machinery, the growth hormone response, the gut repair cycle, the sirtuin pathway, the cellular janitor enough space to run? The answer is far simpler than the biology that justifies it. The human body does not require extended multi-day fasts to access most of these benefits. The research on time-restricted feeding, the practice of confining your eating to a defined window each day, consistently shows that a window of 8 hours or fewer is sufficient to trigger meaningful metabolic switching, autophagy, induction, and sirtuin activation in most people. That means a first meal at noon and a last meal at 8 in the evening, or a first meal at 9 and a last at 5. The specific hours matter less than the consistency and the length of the gap. The process of returning to this pattern, what some researchers call rewilding the metabolism, is not immediate. A body that has been fed across 16 hours a day for decades has calibrated its hunger rhythms, its insulin sensitivity, and its hormonal cycles to that pattern. The first few days of a narrowed eating window may produce stronger hunger signals, mild irritability, or an initial drop in energy as the body recalibrates. This is not evidence that fasting is harmful. It is evidence that the system is adjusting, relearning a pattern it was always designed to run. Within 1 to 2 weeks, the adjustment is typically complete. Ghrelin adapts to the new schedule. Insulin sensitivity improves. The hunger waves become manageable, even predictable. The deep freeze begins to contribute meaningfully to daily energy. And the maintenance windows, the hours of quiet in which the cellular janitor runs, the gut repairs itself, the sirtuins do their work, become a reliable, daily feature of how the body operates rather than an occasional accident. No supplement produces these effects. No pharmaceutical intervention replicates them. The entire cascade, fat oxidation, ketone production, growth hormone preservation, immune rest, DNA repair, is available to every human body at no cost. Through the simple act of allowing enough silence between meals for the system to remember what it was always built to do. You were not designed to graze. You were designed to feast, and then to fast, and to become in the quiet hours between something more repaired, more resilient, and more alive than the version of yourself that ate again before the process could finish.